the only thing causing the tension to all the places, so that's easy. So that comes out to be like 60 newtons. If that's even, right, it's just mg, mass, this mass, times gravity. And then I'm thinking if this, well, okay, the point of this is to pull this leg straight. And if you want this leg to go straight, theta has to be 15 degrees. Oh, it's like not on the bed.
No, it's not.
Oh, okay, so it's hanging in the air. Oh, okay, so that's what they're doing. All right, I immediately imagine this person laying in a bed. But if this is supported in air, then yeah, as Jack said, we have to account for that. So then this, okay, let's see. Let's do a force diagram over here. So we have this. We have this. The weight of the boot. Okay, so, God, this is weird. Something like this. So there's this tension pulling down like this. This one's going like that. And then this one is the mass of the boot times gravity. So this one, if we say this one is, I don't know, T2 or something, no. This one's the bottom, T bottom, this one's T top. And then what would happen here is if this was like a pulley, if this was like going through a loop with no friction, then this would equilibrate out. It would have to equilibrate out to an even weight. But if they fastened it like to a screw or something that's in its cast, then you can have two different forces here. So I guess, but they said the tension's the same. Huh. So there's a pulley here.
Yeah, his boot has a pulley attached.
Interesting. Okay. Well, clearly.
Yes.
Okay. So these two tensions are this, but then this, I don't know. This is going to be theta. That's 15 degrees. So we know this one. Yeah. This one's got to be mbg plus t sine 15. And then this one is just going to be whatever, t cosine theta. This is, of course, t cosine 15, and this one is t sine 15. Okay, like this. So this is mass of the boot times gravity. This is the tension, that's the tension. This is, in order for this not to move, is we have to get the vertical component of this up here, which is this, right? This vertical component has to match the mass of the boot times gravity plus this. So like that, and I don't know, just leave it that way. Little piece right here, t sine 15 degrees. This is t cosine 15 degrees. Do those things all make sense to everyone? Okay. This, of course, is going to be t cosine theta. This is going to be t sine theta, and that t sine theta has to equal the two ones that are down, the two vectors that are down. So that's t sine 15. And so from that, we have our force statement. Some of the force. Gosh, well, I guess technically I'm missing a vector. Well, the resistance from the tension on the leg, I guess. So we can say the force of tension on the leg is going to equal t cos theta plus t cos 15. Does that part make sense? The two horizontal ones are going to add up to be the force of tension in the leg. It's not accelerating, right? It's accelerating? Oh, okay. Jesus, what are they doing to this guy? Right, so we're just saying the force of tension has a reaction force that's the pull on the leg, right? Like you pull outward, the leg pulls back. That's what we're saying. And the force of tension is equal to that pulling back of the leg. So then we're just going to say the force of tension equals this. And then the other one is, of course, I'm going to have to write this. I'll write it in yellow so we can kind of see it over here. This is going to get bigger. We get MB, mass of the, what did I do B? Boot, that's why.
That's why I was like, why?
People called it boot. I would have done cast if I thought about it, but oh well. Plus T sine 15 is going to be equal to T sine theta. So, two equations, two unknowns, right? Oh wait, we don't know the force of tension either. Oh, yeah, oh. We said, oh, yeah, that's right. I'm sorry. Yeah, T is not an unknown. That is a known. So our two knowns are Ft and theta, and we can finish it. It's just the inverse sine of MBG plus T sine 15 over T. And once we find that, we just plug that into here, and we get our traction force. For theta, what do we get? 67 point what? 67.7 degrees. So what for the force attraction? 80.7?